Okay, so as we discussed the same problem in the previous video, where we thought not vectorially but mostly in terms of scalars. For example, we calculated this distance, the shortest distance, and then we proceeded. But now in this video, we are solving the same problem, but we will give emphasis on how to think in terms of vectors. And in this process, we will also introduce the concept of how to use different coordinate systems and transfer data from one coordinate to the other to do jobs. Now let's see what I mean by that. Suppose I define a coordinate system here, which is say x and y. Okay. And in this coordinate system, I am going to solve everything basically. Okay. But then the main problem in this or main issue in this problem is to find out the vectors which are involved in applying r cross f, because see if and I am supposed to find out the moment about this point, isn't it? Now that means if I call this as r vector and this is f, then r cross f would give me the answer, right? So moment about O can be evaluated just by doing this, where r is nothing but this vector. I'll draw with say what, yeah, maybe this. So this vector, if I call r, okay, so the y axis I can take it there, so y. So this is the r vector, r cross with f should be done. But then the thing is how to find out f, because r is very easy. So how much is r in this coordinate system? R is nothing but this is 360, so minus 360, sorry, nj, right? So that's the vector r. But what about f? Now f can be thought of as, in a way, f is equal to minus r plus if I call this vector say as rho. Okay. So then this vector f will be minus r, so this is that, plus rho, right? Shall I write it somewhere else so that, yeah, that's better. Sorry. So I'll write it here, maybe f vector means the arrow, the unit vector to calculate the unit vector in this direction, because the magnitude is known anyway, 4.5 kilonewton. Just I need the direction vector, the unit vector in this direction. For calculating that, okay, I'll say f arrow. Okay, that will be r, or negative r, because r we have taken in this direction, plus rho. Fine. So that if we are able to calculate, then it is done. But then now we should think that again the same problem is coming, because these alphas angles are not very easily you can calculate. So that is what we did in the previous method. We did use trigonometry to solve that problem. But now we will use the concept of shifting to other coordinate system, because now you see this. If I can define a coordinate system which is say x primed and y primed. Now if I take such a coordinate system which is making an angle, I'll show in white color only. Now this angle is 90 minus theta, so it is 50 degrees, right? If I twist this or turn this axis x by 50 degree, I will get this. Now why should I choose that? Because in that coordinate system it's very easy to represent rho, right? Because in that rho in x prime y prime coordinate is nothing but what it's minus 110 in x, so minus 110 I prime I'll write, because I prime is the unit vector in this. Then j is this 340 plus 340 j primed, right? Now if and then so this is very easy to calculate in this coordinate system, and then we can use the fact that how to shift coordinates from one coordinate system to the other when they are rotated with respect to each other. So there is this you can use this that x primed y primed is equal to say cosine of theta. I'll call not theta because suppose this angle, this 50, so this is a gamma. Cosine of gamma, then sine of gamma, then minus sine of gamma and cosine of gamma times x and y. So this is how you can calculate if you know the coordinates in xy frame coordinate system. Their coordinate in x prime y prime can be figured out from this, which I call this say rotation matrix. Or if you invert them, you can always calculate xy xy to be equal to cosine gamma minus these are space constraint, so cosine gamma minus sine gamma, then sine gamma and cosine gamma. This is just the inverse of the other. This you can use to figure out x prime y prime. Okay, so that means now because we know the coordinates in the primed coordinate and we want their values in unprimed or the xy coordinate, we can simply use this. Okay, now so that means now gamma is this 50 degree, and if you use them you can figure out the components in xy coordinate for rho. So that means if you do that, the values if you substitute here, you will get rho in xy. It will come out to be I've done that, yeah, minus 331.16 and 134 point 134.28. Okay, the one which was in minus 110 and 340 in x prime y prime, it is minus 331 and 134 in xy coordinate system. Okay, so this has been calculated just by substituting here x prime y prime to be minus 110 and 340, and here gamma is 50. So you calculated xy, and this x is this y is this. Okay. Now once you calculated that, now it's very easy, right? So we have calculated this, r is known, so f is known, and you can simply calculate with moment with this, yeah, r cross f. So that's the another way of thinking that, so this I would call thinking vectorially. So everywhere we tried to use the concepts of vectors, and in addition we used how to change different components of the same vector. See here the same vector rho is getting represented in two different coordinate system. One is primed one is the unprimed one, and we just use that transformation property of vectors components from one coordinate system to the other to figure out rho from this to rho from this, because this was very easy to do in this primed coordinate system. This is easy to do computationally. So this difficult thing which was difficult to do in xy frame, we could do by two simpler processes, and then we just add them and we get it. And m, if you do, you will get m naught to be minus 0.902 at k, okay, kilonewton meter, in kilonewton meter. Okay, so that's the method which I was referring to when I was saying second method we will see. So see you in some other video with some other problem. Thank you.